Now, we don't know exactly how language works, but we can seek to describe different possible ways of combining words into sentences. And a formal description of all of the different sentences in a language is called a grammar. We're going to work on something called a context-free grammar, which is a collection of rules where each rule describes how a tag can be expanded as a sequence of tags or as a word. So for instance, we'll have context-free rules that look like this one, which can be interpreted as a sentence can be expanded as a noun phrase, then a verb phrase. So here's a more complete grammar, which is a collection of rules. We have the one above, and that allows us to construct a sentence out of a noun phrase and a verb phrase. Then we need to know how to expand a noun phrase. A noun phrase could be just a noun, and a noun could be the word buffalo. So in this way, by recursively expanding symbols, we start to generate sentences. So far, we have a noun buffalo as our subject. More grammar rules will allow us to fill out the rest of the sentence. How shall we expand the VP or verb phrase? Well, we can expand it as a verb and then a noun phrase. What verb? How about the verb buffalo? So now we know that we have buffalo, that buffalo. And what do they buffalo? Well, we expand the noun phrase to get a noun, and the only noun we have is buffalo. This recursive expansion process is the heart of most natural language parsers. So let's take a look at how it works. Here's a new file, parse.py, which has our tree and leaf classes, as well as our print tree function. We're now going to create the different pieces of the grammar. The leaves are going to go in a set called the lexicon, and the rules that expand into trees are going to go in this dictionary called the grammar, which goes from the left side of the rule to different possible expansions for the right side. And in this case, we only have one way of expanding an S, and that's to an NP and a VP. So what does it mean to expand a tag? Well, one possibility is that we expand it into a leaf. So let's go through every leaf in the lexicon. If it's the case that the tag is equal to the leaf's tag, then we can yield that leaf. Another possibility is that this tag appears in the grammar dictionary. So if the tag is in the grammar, then we want to go through all different sequences of tags that it can expand to. For each of these, we want to expand it into a whole branch of the tree. And that means expanding all the tags. First noun phrase, then verb phrase. And then we can yield a tree with the tag at the root and the branches as the branches. What does it mean to expand all tags? Well, tags is a sequence of tags. If the length of tags is just 1, then there will be only one branch. For that branch, which we get by expanding that tag, we can just yield the branch. Now we actually want to yield sequences of branches, so let's surround that in brackets to make it part of a list with only one element. So one tag comes in, one branch comes out. Otherwise, we need to handle all of the different tags and turn them each into a branch. We can do that by recursively splitting them into the first and the rest of the tags, and then considering all the possible ways in which we might build the first branch out of the first tag, and all the way of expanding the rest of the tags into the rest of the branches. What sequence do we yield? Well, we put the first branch in a list, and we concatenate that with all the elements of the rest branches, and then we have a list of all the different branches. Okay, what are we going to do with this expansion? Well, let's just print it out to see what we have. So for every tree, that we get by expanding the S symbol for a whole sentence. Let's print tree of that tree. We run this program and it prints out buffalo, buffalo, buffalo. So it expanded S into NPVP, the NP was expanded into N, and N was expanded into the word buffalo. Now if we add more alternatives to our grammar, then we'll get different sentences. So let's say it's not just the case that a noun phrase can be a single noun. It can also be an adjective followed by a noun. An adjective is some word that modifies a noun. Like, where are these beasts from? Some of them we said were from Africa, but maybe others are from New York. What part of New York? Buffalo, New York. So if I want to say someone's from Buffalo, I'll say, oh, that Buffalo gentleman. And if I want to say a buffalo's from Buffalo, I will say, oh, that Buffalo, Buffalo. So let's add a new leaf, which is Buffalo. And it means to be from New York. Particular city in New York, Buffalo, New York. Now if we run the same program, we'll see that there are 4 different sentences we can create. The beasts intimidating the beasts intimidating the New York beasts, the New York beasts intimidating some beasts, and finally, the regional conflict, New York beasts intimidate New York beasts. We can expand our grammar further in order to find more interesting sentences. So it's not just the case that a noun phrase can have only a noun and an adjective. It can also have a noun phrase followed by a relative clause, like we saw in our example sentence right at the beginning. So a relative clause describes something about the noun. Like, what is it about these buffalo? Well, maybe they're being intimidated themselves. How would I express that? Well, I'd have a relative clause which started out with a relative pronoun, which is the word that. So now we can say things like the buffalo that other buffalo intimidate all live in New York, or whatever. Okay, so there's the that. We need to have a subject of the relative clause, and then we need to have a verb. And what happens when I run the program now? Well, I'm going to pipe it into another program less, which will let me scroll through the output, because I'm worried there will be a lot of output. We still have the sentence that buffalo, 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 and the sentence that buffalo, buffalo, New York, buffalo. But now we have something new. This one says that beasts intimidate beasts that other beasts also intimidate. So now we have this poor set of buffalo right here being intimidated not only by the subject, but also by the subject of the relative clause. Buffalo, 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 that buffalo, buffalo. And to add insult to injury, we even have a sentence that says, the buffalo, 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 that New York buffalo, buffalo. But perhaps more interesting is the fact that there's a cycle of expansions. An NP can be an RP, which contains an NP, which could have an RP. Now this is optional. Not every NP has an RP. It could be the case that you just have a noun or an adjective and a noun. But in the case that you actually have a relative clause within the relative clause, you get sentences such as this one. Buffalo, buffalo, buffalo. That buffalo, buffalo, buffalo. And they can become arbitrarily long. Buffalo, 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 that buffalo, 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 buffalo. Now you might wonder whether the word that is required at all. I can say, the tree that the man chopped down is now a log. Or I can leave out the word that. The tree the man chopped down is now a log. Buffalo, 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 buffalo. I express that by having an alternative expansion for RP that's just the subject and the verb of the relative clause. So now we can have an interpretation for an arbitrarily long sequence of the word buffalo.